So it would have been very useful if I had actually hit the record button the first time, because I talked while it was not recording. All right, so speed is the absolute value of velocity, and therefore it cannot be negative. You'll notice I've done all the highlighting already. And so when I want to figure out if speed is increasing or decreasing, I have to check both velocity and acceleration, and I have to check to see if their signs are the same or their signs are different. If they're the same, it means I'm increasing. If they're different, it means I'm decreasing. And you will see multiple choice questions about this concept across the entire semester/year. So you do have to remember this. It seems a little isolated right now, and you don't get asked a ton right now because they spread it out over the course of the whole year. So something you might want to put on a flashcard to save for the entire year. And thirdly, acceleration tells us the rate at which the object is changing velocity. There should have been a blank right there. I don't know what happened to it, so you definitely want to fill that in. And the notation will always be a of t for acceleration, and it's the derivative of velocity, first derivative of velocity, or second derivative of position. And you might have already guessed, so after I take the first derivative, which would be velocity, then I would take the second derivative. So those are the same thing. First derivative of velocity is the second derivative of position. Okay, so let's look at some examples. Okay, so of course it's important that you read it first, so I'll let you read it and note some things as you're going. So this would be initial height. There's my s sub 0, and here's my position function. And so I want to find average velocity. So when I go back and I look at V average, I know it's S of B minus S of A over B minus A. And so I got to do two different problems here. The first one is from 1 to 2. So I need S of 1. Actually, I'm going to do the later one first. That would make more sense, right? So S of 2 minus S of 1 over 2 minus 1. It shouldn't make any difference, obviously, what order I subtract them in, but this way I save myself some time of not having to deal with negative numbers. So if I plug in 2, S of 2 will give me negative 64 plus 100, so that's 36, minus S of 1 is going to give me 84 over 1, and so I get negative 48, and this would be feet per second for velocity. And then it wants to know what the average velocity is for this time. So the second time, I'm gonna do S of 1.5 minus S of 1 over 1.5 minus 1. And if I substitute in 1.5, I get 64, and S of 1 is 84. Double check with your calculator. We know that sometimes I've been known to do bad math. Over 0.5. And if I simplify that down, I get negative 20 over 0.5, which is negative 40. Again, feet per second. And the last question it asked me is, how's the ball moving? Well, I notice that they're both negative, so that tells me that it's moving downward, which makes sense because, hey, I dropped the ball off of a billiard table. So, of course it's moving down, it's going to the floor.